This is just the opposite of the NOT gate. So these are the basic gates. Next is universal gate. That we discussed two universal gate. One is NAND gate, one is NOR gate. What happens here? NAND is basically a combination of AND gate plus NOT gate. So what is AND? Suppose we have two inputs A and B. Then AND output is what? A dot B. Then it is given to a NOT gate. So what is the output of a NOT gate? It is the complement. So in NAND gate output is A dot B whole bar. A dot B whole bar. Okay. Again AND gate we are representing with this followed with a NOT gate. If it is AB, this will be Y equal to A dot B whole bar. So symbol of NAND gate is directly a bubble will be placed here. A, B, so this will be A dot B whole bar. So you can see here, okay, this is the symbol of the NAND gate. These are the two input NAND gates, two input NAND gates. Similarly, multiple input NAND gates are possible. So three input NAND gates are possible, four input NAND gates are possible. So suppose three input NAND gates will go for, then we'll have three inputs A, B, C. So here Y will be equal to A dot B dot C whole bar. Okay. Now coming to its truth table, what will happen to its truth table? If we have two input, how many possible combinations will be there? How many possible combinations? दो इनपुट अगर होगा तो कितना इनपुट पॉसिबल कॉम्बिनेशन होगा? Four possible combination. So now suppose these two are two inputs xy. Okay. So this is 0 0 0 1 1 0 1 1. Okay. So let me write again with the help of AB 0 0 0 1 1 0 1 1. Okay. Let us first find out A dot B. What will be A dot B? How many zeros? First combination 0. Next combination 0. Next 1 dot 0. एक 0 है so 0. Last is 1. Next A dot B whole bar means this one's complement. So 0 means 1, 0 means 1, 0 means 1, 1 means 0. Okay. So now if we define this NAND gate, what can we define? If any of the one input is 0, then output of NAND gate will be 1. Any of the one input is 0, then output will be 1. Otherwise output will be 0. Similarly, NOR gate, क्या होना चाहिए NOR gate? What will be NOR gate? Not plus one. As this name suggests, NOR gate is
or plus not.
Or plus not. So symbol is this one. Or then a bubble is used. Okay. It is represented with A plus B whole bar. Okay. Now suppose again two inputs I will take AB. This will be A plus B 0 0 0 1 1 0 1 1. So if you add them, what you will get here? First combination
0.
0. Then 1. Then
All 1.
Then its complement. So this one's complement, zero's complement is 1. 1's complement is 0. 1's complement is 0. 1's complement is 0. So what is the definition of A plus B bar then? Or NOR gate's output? If both the inputs are 0, then only your output is 1. Otherwise your output will be 0. Okay. So this is the NOR gate. Now let us see why it is called as universal gate. It is called as a universal gate because using this we can implement all other basic gates. Okay. Now suppose I want to implement a NOT gate with the help of NAND. Then what can we do? In NAND gate, two inputs are there. Suppose x, y, this is x dot y whole bar. NOT gate, how many inputs are there? One input. Suppose A bar is there. Then what I can do here? How can I get? What modification I can do here? Means where I will apply A and what can I do?
So we will take A is equals to x dot y.
A equal to
X dot y.
A equal to x dot y. Okay, that means you are saying here you will take x dot y equal to that, so you'll get A bar. That means what? That means
Yes, sir.
this is the
So we are
output.
combining both the inputs.
Combining both the inputs mean here in input side what will happen? Output side it is correct. That is the end result what I want. The input what I should do. Where I should apply the A. So basically I need to short both the inputs. Okay, that means both the input should be A. If both the input will be A, then what will happen? Output will be A dot A whole bar. What is A dot A? Logical AND operation. A dot A is nothing but A only. So it will be A bar. Okay. So by sorting both the input of NAND gate, if we short both the inputs, it will work as a NOT gate. Is it clear? Is it clear?
Yes, sir.
Now, next one.
Yes, sir.
Now suppose NAND gate, I will implement from NAND gate, I want to design a AND gate. Then what I should do? I have with me this, I have this x dot y whole bar. Okay, I want to implement AND gate. Then what to do? AND gate का output क्या होना चाहिए? If suppose two inputs are there x y, then output
X
should
dot
be x
y.
dot y. तो क्या कर सकते हैं यहाँ पे? ऑलरेडी बार है, बार को हटाना है, तो क्या कर सकते हैं?
That not लगा दो.
एक नॉट गेट लगाना है, but NOT gates are not allowed. We need to implement using NAND gate only. So how NOT gate can be implemented using NAND? By shorting both the inputs.
Yes, sir.
Okay, so here we can get x dot y. Okay, now NOT gate over, NAND gate over, NOT gate and AND gate over. Next is OR gate. Now, okay. Now what I am doing, before NAND gate, I am connecting two NOT gates. So what will be input to this NAND gate? Here what I will get, if input is X, this is NOT gate. What will be input here? यहाँ पे क्या आएगा? This output. What will happen to this output?
X.
X bar. Here
Y bar.
Y bar. Now this X bar Y bar are inputs to this NAND gate. NAND gate what happens? NAND gate output happens to be whatever the two inputs. Suppose input is A B, then A dot B whole bar. Now in place of A what is there? X bar is there. In place of B, Y bar is there. It's complement. Okay. So now this is the whole complement. Okay. So do you remember about this De Morgan's theorem? Do you remember?
X plus Y.
A dot B whole bar is equal to A complement plus B complement. So यहाँ पे क्या हो जाएगा? X double complement plus Y double complement. So double complements cancel each other. So this will be X plus Y, which is nothing but a OR gate, which is nothing but a OR gate output. So what we used to do, instead of doing like this NOT gate, we used to represent like this NOT gate. In place of NOT gate, we can simply use a bubble. Bubble signifies a NOT gate. Okay. So this is called as a bubbled NAND gate. So bubbled NAND gate is same as OR gate. Okay. Bubbled NAND gate is same as OR gate. So similarly, you can try with the OR gate, or you can try with NOR gate also, how we can implement different basic gates with the help of NOR gate. That you try with yourself. Same thing, similar way. Okay, you can see here same thing. Next. Next two gates are called as XOR gate and XNOR gate. XOR gate and XNOR gate. XOR is stands for exclusive OR, XNOR stands for exclusive NOR. So first, XOR. So XOR, the symbol is this. This is X, this is Y. The symbol is plus inside a circle. X XOR Y. So X XOR Y is actually X bar Y plus X dot Y bar. Okay. So the point to remember here in exclusive OR gate is exclusive OR gates are available only in two input. So multiple input XOR gates are not available. Multiple input XOR gates are not available. That was possible in AND gate, OR gate, NAND and NOR. Same thing is not possible in this XOR. Now what happens here? If I have two input, how many possible combinations are there? Four possible combinations. Okay. So ultimately I need to find x bar y plus x dot y bar. Let us find it one by one. If I'll write x bar, what will be x bar? X bar will be 1 1 0 0. If I'll find y bar, it will be 1 0 1 0. Next, if I'll write x bar dot y means this dot this 0 dot 1 0 1 dot 1 1 0 dot 0 0 1 dot 0 0. Next, x dot y bar means this and this column, first and fourth column,
0 0 1
0 1 0 0 0 0 1 1 1 1 0 0. Then we need to add them x bar y plus x dot y bar, which is nothing but x XOR y. Okay, so what happens if you add this 0 1 plus 0 1 0 plus 1 0 plus 0 0. So if I'll remove all this, or you can concentrate on this table now. So finally we got this as output 0 1 1 0. So what this signifies, this exclusive OR tells us about the dissimilarity, or this output will be equal to 1 when both inputs will not match. When both inputs will be different, then only output will be 1. So this combination both inputs are different, this combination both inputs are different. So because of that, output is 1. First case both are same, last case both are same, so output is 0. It comments about the dissimilarity. If both are not same, then only your output will be 1. Otherwise your output will be 0. So next is XNOR gate. XNOR gate. It is just the opposite of the XOR. Okay. So what happens here? In the same symbol, one second. The same symbol, we need to add a bubble here. Okay. This symbol will be X dot inside a circle, which is equal to X XOR Y's complement. Okay. So because in XOR symbol only I'm adding another bubble. Bubble means nothing but a NOT gate. One second. Okay. So X XOR Y complement. Okay. Because in XOR gate only I'm using a bubble here. In XOR gate I'm using a bubble. Okay. So that means output has to be this complement. So can you simplify what you will get here if you will take complement of this? कितना आएगा? X bar Y's complement dot X dot Y bar's complement. Okay, so the task for you, if we'll keep on simplifying, finally you will get x dot y plus x bar dot y bar, xy plus x bar dot y bar. So if we'll find out that how much you'll get here, so what will happen? Let us find out xy first. What will be x dot y? 0 dot 0 0, 0 dot 1 0, 1 dot 0 0, 1 dot 1 1. What will be x bar? X bar is complement of x, both are 1 1 0 0. Y bar complement of y, so 1 0 1 0. So what will be x bar dot y bar? This two, 1 dot 1 1.
1000.
So if we'll add this two, this one and this one, xy plus x bar y bar, then 0 plus 1 1, 0 plus 0 0, 0 plus 0 0, 1 plus 0 1. So what happens here? Now concentrate on this. Okay. So what happens here? It comments about this XNOR gate, comments about the similarity. If two inputs are same, then only your output is 1. Otherwise, your output will be 0. Okay. So this is the XOR gate and XNOR gate. Up to this, is it clear?
Yes.
Yes, sir.
Okay. So now a task for you. You find out how can we implement a inverter with the help of XOR gate. Then we'll see for XNOR gate. Okay. So with me, XOR gate is available. XOR gate is available. Okay. I want to implement a NOT gate or inverter. Remember, whenever you are designing any circuit, okay, always with you, one zeros are available with you. Okay, so check how you can implement this XOR, how you can implement this NOT gate with the help of XOR gate. Anyone got it? Just observe this truth table. You get an idea.
So we are allowed to use only XOR gate.
Yes, we using only XOR gate. We need to get the inverter. So here this is output is x dot y bar plus x bar dot y. Suppose input is A, then output should be A bar. So with you, A is available, 1 is available, 0 is available. These things you can take as input. 1 and zeros are always available with you. Whenever you are designing, 1 and zeros are always available. Just compare this. This needs to be A bar. Then what to do? How that can be A bar? So suppose anyone, any idea?
So if the complement is a
If no, if X is A, then this will be A bar. Okay. If it is A bar, what should be the value of Y? क्या होना चाहिए? Ultimately output A bar चाहिए. तो A bar dot क्या होना चाहिए? कि A bar ही आएगा.
1.
Yes.
1. If Y is 1, what will be Y bar? Y bar will be 0. First should
Yes.
be X. X is already taken as A. What is A dot 0?
Yes.
A dot 0 is 0. Plus A bar dot 1 is A bar, which result is A bar only. So basically what you did, in place of x, you applied a. In place of y, what you applied? You applied 1. So if you apply a to one input, 1 to another input, you will get output as a bar. Okay. Now a reverse question. Suppose you want to implement a buffer, then what to do? Buffer means output should be a. Output should be a.
एक्स को ए ले लेंगे
x को
और
ले लेंगे तो y बार क्या होना चाहिए?
1.
So y को 0 ले लेंगे.
हाँ, y बार अगर 1 है, then y should be 0. This should be a bar. So if you add this, you will get a only. So one input has to be a, one input has to be 0. Similarly, you can try for XNOR also. Similarly, it will just be reverse. Okay. So later on, you can try
Okay,
for
sir.
XNOR, how it will be implemented as a buffer and inverter. Now, because this 3 input NAND gate, 3 input or 4 input XOR gates are not available, which was possible in case of AND gate, OR gate, NAND gate, NOR gate, then what to do? Okay. So for that purpose, suppose you want to find out A XOR B XOR C. So what to do? First of all, I will find out A XOR B. Then we need to find out this result XOR with C. So basically, we need to go for 2 XOR gates. A, B, then this. So here you can get A XOR B XOR C. So as we have 3 inputs, total 8 possible combinations are there. So let us check what will happen to output. 1 second. So let me write. So how we will solve it? First we'll find out A XOR B. So check this to column and tell 0 0. What will be output for A XOR B?
0.
0. 0 0 0.
0.
0 1 0 1
1.
1 1. 1 0 1 0 1 1. 1 1 1 1, both are same.
0 0 0.
Okay. Now this result XOR with C, which will be F A XOR B XOR C. So 0 0 0
0.
1 0 1
1.
0 1 1 1 1 0 0 1 1 1 1 0 0 0 0 1 0 1. Okay. So same thing is mentioned here directly. Same thing is mentioned here directly. Just verify 0 1 1 0 1 0 0 1. Okay. Now we need to go for a shortcut so that we can. It is not possible that every time we'll write A XOR B, then we'll find out A XOR B XOR C. So we'll go for a shortcut here. What is the shortcut? You check the combination in which output is equal to 1. This is, this is, this is, this is. So count number of ones in those combination. How many ones are there in each combination? In first combination, how many one is there?
1.
1. Next,
1.
1. Here, again 1. Here,
3.
3.
3.
Check number of 1 in other cases. Here,
8.
let me take another color.
2 or
1
0.
second. This is 2, this is 2, this is 2, 0. So your output will be 1 only when odd number of ones are present. If odd number of ones are present, only for those corresponding combinations output will be 1. Otherwise your output will be 0. So now onwards, when you write the truth table, just count the number of ones. Only when number of ones are odd, then corresponding output will be 0. Otherwise it will not be 1. Okay. So for this combinations only, your output will be 1. Okay, this is the shortcut for this. Next, Boolean algebra. So when we are dealing with only two options with 0 and 1, okay, so this algebra is nothing but Boolean algebra is nothing but a mathematical system for manipulation of variables that can have two values. Two values means 0 or 1. Okay. So again, that name can be true or false, it can be on or off, this can be high or low, or this can be 0 or 1. Multiple naming is possible. So whatever variables we use here, maybe A, B, C, and its complement A bar, B bar, C bar, all of these are called as literals. L-E-T-R-A-L-S. They are called as literals. So Boolean expressions can be created by performing different operations on this variable. So different functions can be created by doing the operation. So a Boolean operator can be completely described using truth table. Suppose I will take any function, okay. So that thing you can find out using the truth table, like we did in the previous cases. So directly whatever function you have, function f, you can directly find out by going through the truth table. What will be the output? So a Boolean algebra compromises of following thing. What are those things? A set of element means this literal, so variables a, b, c or x, y, z or p, q are different variables, or its complement a or a bar, b or b bar, c or c bar. Then binary operator plus or dot. Then a unary operation means complement. So with the help of this, we'll be able to go for any kind of function. We want some variables or literals. Apart from that, we want these operators plus, dot and complement. So with the help of this, we can go for any kind of function. So there are certain axioms and laws that we need to follow in this Boolean algebra. So these are again nothing but the logical operation that we discussed. 0.0 is 0, 0.1 is 0, 1.0 is 0, 1.1 is 1. This is nothing but the AND operation. Next is OR operation that we discussed. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. Next, complement. 0's complement is 1. 1's complement is 0. Now, if A is 0, what will happen to A complement? A अगर 0 होगा, A
One.
complement must be 1. Similarly, if A is 1,
One.
what will be A complement? A
Zero.
complement will be 0. Now, if you have a variable A, you take A dot 0. What will happen to output? A can take two values. A can be 0 or 1. So 0.0 or 1.0, only two
Zero.
possibilities. So each time it will be 0. So A dot 0 is always 0. What will be A dot 1? Again, two possibilities. Two values are possible for A. It can be 0 or 1. What is 0.1? 0.1 is
Okay.
0. No, 0.1 is 0. 1.1 is 1. Okay. So it will be depending upon the value of A. So A dot 1 is A. What will be A dot A? So again, only two possibilities. Either it can be 0.0 or it can be 1.1. So this will be 0 or this will be 1. That means A dot A is same as A. A dot A's complement, this will be 0.1 or 1.0. Each time output will be 0 only. So A dot A bar is
Zero.
0. Similarly, A plus 0 is A plus 1 is 1. No, A plus 1 is 1. 1 को किसके साथ ऐड करेंगे, लॉजिकल ऐड है तो 1 ही आएगा.
Yes, sir.
A plus A only, A plus A bar 1. So these are
Yes.
the different axioms. Next is duality. Okay. So what happens in Boolean functions, if any function is there, okay, suppose any function, suppose I will go for A dot A bar plus B dot 1 is equal to A dot B. If any function is given, this is a Boolean function. It consists of variables and the operators, maybe unary operator and dual operator. Now, any function is given. If any function is given, there will be a dual of this. What will be dual? So dual, what happens? Dual we can get by changing dot to plus, plus to dot, 0 to 1 and 1 to 0. So what will happen? This is A dot, so it will be changed to A plus, A bar, this plus will be changed to dot, then dot 1, so dot will be changed to plus, 1 will be changed to 0, this will be equal to A dot B, dot will be changed to plus. So this function is the dual of this. Then what is the importance of dual? So once any theorem is proved, then its dual is also proved. If any function is true, anything is true, then its dual is also true. No need to prove it further. If any function is true, its dual will be also by default, it will be true. So how to get the dual? By interchanging dot with plus, plus with dot, 0 with 1 and 1 with 0. Let's take another example. Now suppose a function is f is a dot b plus a bar dot c plus b bar plus c plus d. So what will be its dual? क्या होना चाहिए dual इसका? क्या होगा dual इसका?
A plus B
Okay, a plus b. This dot will be changed with plus.
dot
Then this plus will
dot
be changed with dot. A bar dot will be changed with plus. This plus will be changed with dot. Then b bar plus will be changed with c dot d. So this is the dual of this function f. Okay. Next is De Morgan's theorem. So De Morgan's theorem is used to
Sir,
find. Yes.
so dual of 0 is 1 and 1 is 0, then shouldn't be A complement as A and C as C complement?
No, complement is different. We'll come to that complement. Complement we are
Okay.
not changing. Just we are going for the dual. Dual means we are only interchanging zeros with 1, ones with 0, then zeros with 1 and plus with dot and dot with plus. Only that much.
Okay, sir.
So this will be helpful in complementing. So next we'll see that. So in De Morgan's theorem, what we'll do, we'll find the complement of any function. Okay. So basically there are, as per De Morgan's theorem, you know that A dot B whole bar is A bar plus B bar. Similarly, A plus B bar is A bar dot B bar. Okay. So this is the simple functions A dot B whole bar and A plus B whole bar. Suppose a complicated function is given, means long function is given, then how to find its complement? So for that purpose, you need to follow the steps. What are the steps? First, you need to replace dot with plus, plus with dot, 0 with 1 and 1 with 0. That means what? Basically what you are doing. If you are interchanging this, that means what? Basically you are finding dual only. Okay. So whatever function is given, first you need to find the dual of that function. Dual of that function. Then you need to replace all variables with their complement. So whatever variables will be there, you need to change with its complement. Okay. Let us see an example. So suppose function is given as this a plus b dot a bar plus c. This is the function. We want to find out its complement. Okay. Then what to do? What will be f complement? पहले क्या करना होगा, उसका डुअल निकालना होगा. डुअल क्या होगा? a plus b will be a dot b. This dot will be changed with plus. This will be a bar dot c. What is the next step? We need to replace each variable with its complement. तो क्या हो
Complement.
जाएगा? This will be complement. This will be complement. This will be complement. This will be complement. So here it becomes double complement. Double complements cancel each other. So what will happen? So complement of f will be a bar dot b bar plus a dot c. Okay. So next are the different laws. Okay. First is identity law. So as already discussed, if one input is x, so x plus 0. What will be x plus 0? X plus 0 will be x only.
X.
So what will be its dual? Dual will be x plus will be replaced with dot, 0 will be replaced with 1. This will be this. So this is correct means this is also correct. Okay. X plus 0 is also 1. X plus 0 is equal to x. X dot 1 is also equal to x. So this is called as the identity. Next is null. In null, what happens? X plus 1. What will be x plus 1? If you add something, if you were doing logical addition, if you are adding
1.
something with 1, result will be 1 only. Its dual is also true. What will be its dual? X dot 0 is equal to 0. If you are logically multiplying or logical AND, if one input is 0, so obviously output will be 0. Next. Next is add append. So what happens here? If you add, logically add same variable x plus x, then output will be x. So its dual is also correct. Next, involution. If we take double complement, then it cancels each other. Next, complementary. So what happens? If we go for x plus x bar, what will be the result? You are adding x with its complement. So if x is 0, x bar is 1. This will be 1. If x is 1, x bar will be 0. Its addition will be 1. Okay. So what happens? X plus x bar will be always equal to 1. Similarly, its dual is also true. X dot x bar will be equal to 0. Next, commutative. In commutative, x plus y is same as y plus x. Okay, that means you can interchange these inputs. Suppose AND get xy, sorry, और गेट ले लेते हैं, और गेट डिस्कशन किया है. So meaning will remain same. So you can interchange these inputs. Still your result is same. So x plus y is same as y plus x. So x you can apply here or here. It doesn't make any changes. If two inputs are same, then the result will be same. This is called as commutative. Next, associative. What is associative? X plus y plus z. Check. X plus y plus z is equal to x plus y plus z. What do you mean by this expression? Can you comment on that? What do you mean by this? What do you mean by this x plus y in bracket here? And what do you mean by y plus z in bracket here? क्या मीनिंग है इसका?
Order of operation does not matter.
X plus Y should be done first or something like that. Yes.
No, no. Think in terms of this logic gates. What will happen? X plus y then plus z.
Yes.
Order change means order change हो गया, ठीक है. In terms of gate, what will happen? X plus y means what?
First we will take input as X and Y
X and y. Its result will go
in
to
our
x.
gate.
This will be x plus y plus z. So it is same as,
Yes.
if we change it to yz, this will be y plus z. Then we are taking another input x. So it is same as x plus y plus z. So it is called as associative. It is called as associative. So this and or operation and operations are both associative and commutative. Similarly, you check for other gates. They are associative or not, commutative or not. Next is distributive. Distributive means x dot y plus z is same as x dot y plus x dot z. Similarly, its dual is also true. So this one you are comfortable with. X dot y plus z. We know that if you open the bracket, this will be x dot y plus x dot z. So its dual is also correct. What is its dual? X plus y dot z will be equal to x plus y dot x plus z. Okay. So these are correct. Next one, next one is uniting. In uniting, what happens? X dot y plus x dot y bar is equal to x. So what happens? I can take x common here. If I take x common, what will happen? It will be y plus y bar. What is y plus y bar? What will be y plus y bar? Y plus y bar is 1. So x dot 1. What is x dot 1? X dot 1 is x. So it is called as uniting. So dual is this, which is equal to x. Okay, let us stop here. Next class we'll go for the remaining.
Okay, sir.